welcome to everyone. I think this has been, this is the third or fourth year, I believe, that we are running this annual webinar wherein we invite all the guests to review the work that are done by our interns. Today, I'll just take 5 minutes to go through a couple of works that we have done over the past 3 years and take you all through it. So over the past 3 years, we have at MRC, we have developed around 48 different projects, which can be distributed across 9 different domains. And all the projects, all the work that you see is essentially efforts that are done by 100+ interns, research fellows, and engineers who all work on it together. We essentially follow an incremental model at MRC, wherein every work that we do is essentially we categorize it. The interns come in, they perform, they create a proof of concept of their particular research work. Then we look at the viability of that particular project, and then it is taken forward by the research fellows. Most of the interns, these research fellows essentially are the interns who stay back with us to complete their work, and wherein they feel that they would like to contribute to the underwater domain awareness framework, and they want to take the project forward and dive deeper into the study per se. So all of our work, we can essentially distribute that into different domains, starting like varying from AUV design and development, shipping noise and vibration studies, up to aquaculture and economic analysis, and climate change analysis, and its impact of it on the environment, specifically in the UDA aspect. So to quickly take you through a couple of works that we have done, some of the notable works that we have done. In AUV design and development, we have created a AUV design, which essentially is primarily used for extraction of polymetallic nodules. We know that it is due to the increase in depth, it has always been an area of concern, an area of effort per se. So we created a design which essentially includes both primary and secondary AUV. And we have, as you can see in the images, we have created subsystems for these. The idea therefore is that there's a primary AUV, there's a secondary AUV, and then the secondary AUV can detach and then go forward and then perform the picking of polymetallic nodules, and then get attaches back to the primary AUV. In that way, we essentially save the energy, as well as the secondary AUV is essentially autonomous with a separate mechanical arm to perform the extraction. The second one I would like to take you through is a passive sonar simulation project. This is something that we started with a couple of years ago. The core idea behind this is the effective, like creating a model which can perform effective detection and vulnerability assessment. So any submersible, whether autonomous or non-autonomous, when we submerge it within the water column, at what particular depth can we submerge it so that we can have the most effective deployment there? That is the proficiency of the sonar, the performance of the sonar per se is at maximum at that given particular region. That is something that this passive sonar simulator will essentially give us. And at what depth are we more vulnerable to the receiving signature? So if an adversary is trying to use their sonar to identify us, at what depth? So there are certain areas such as shadow zones in the water where the signals cannot reach effectively due to the way the environmental aspects are there, the temperature, salinity, and how the signal essentially propagates. So we identify those shadow zones. We identify those zones where you get the maximum performance if you deploy any autonomous or non-autonomous vehicle underwater, and that is what this particular project is all about. Then we have essentially done some work in basically assessment of environmental and water quality. In specifically, one thing that I would like to take all of you through is essentially for the Brahmaputra area. So the idea there again was to assess the vulnerability of urban area for flooding. So this basically involves the topography, land use patterns, drainage systems, and hydrological characteristics that we take into account of the watershed to identify the areas of high risk of flooding. The urban flooding modeling helps in designing and optimizing sustainable drainage systems that can effectively manage the stormwater runoff per se. We have done some work in shipping noise and vibration studies as well. I think this is one of the work that we have been well renowned for, and this is an amalgamation of this work is what we presented in IMO as well, which was taken forward, I believe, as part of MVPC 76. The idea again is essentially to identify instantaneously at any given point what are the different ships in the particular region and what is the noise that is emitted by those particular ships. So the image that you can see above showcases the black dot showcases the ships in the Indian Ocean region, and the colored map showcases the noise that is emitted at a frequency range of 100 Hz. This essentially is done for marine spatial planning. the stakeholders are many, but to identify a few, definitely the marine mammals, because the noise that we generate is at the same frequency level as that of marine mammals. Yeah, basically identifying which areas is of high risk and which areas of low risk. And of course, there are other factors that come towards the maritime security as well. A high noise area means deployment of any kind of equipments will have more noise, and the signal to noise ratio, again, that signal we'll have to do a lot more denoising to identify what the signal is. Over the years, we have also used AI to enhance our effort. So 2 years ago, we put our first publication wherein we were the first one to use neural network to estimate the transmission loss that happens underwater. We have made a publication wherein we have constructed a neural network which is specifically trained for the Indian Ocean region, and that for any given point A and B in the Indian Ocean, we estimate the transmission loss per se. So the graph that you can see below, it showcases how our neural network compares to the existing PyRAM model, which is the mathematical model that is usually used. The main reason for this is that as we are moving towards an instantaneous noise calculation, we want an algorithm that can instantaneously provide transmission loss as well, because that's the core point for estimating the noise. And therefore, as you can see in the graph, a mathematical model, a usual model, will take a linear time. So as in when the sender receiver pairs, in this particular case, the ship and the receiver point, as in when the sender receiver pair increases, the amount of time taken to perform that computation increases. But in neural network being a different, using a different strategy, we were able to reduce it to a logarithmic time difference between 0 to 5 seconds, regardless of the number of observations, number of sender receiver pairs per se. We have also done a lot of work for sediment management and river studies per se, and identifying how we can perform sediment classification. Of course, there is also some work that is done by one of our PhD candidates, Jyoti Satalge. One of the research fellows will essentially take you through the data that we obtained from that and how we extracted useful information from it. But yes, the idea is therefore to identify that from the environmental parameters and from different studies, how can we identify what type of sediment is there under the freshwater systems. And the sediment, when you perform dredging, so what do we do of this particular sediment after you perform dredging? What is the use case for this? For all of this, it is important that we identify the type of sediment first, whether it is a clay silt or a silty clay kind of a thing. So that composition helps us to derive what is the use of the sediments that we will have after we perform the dredging for that particular region, and so on. So we have again done some essential work for snapping shrimp mapping. Snapping shrimp, as we all know, creates noise at close to 100 decibels, which is and also at the frequency range similar to that of what we use in our systems underwater. That basically means that they heavily interfere with the operation of our systems that we have underwater. We have done some important work in snapping shrimp mapping, identifying in which region we'll be able to identifying what are the regions in which snapping shrimps are found and what are the regions where the possibility of them being there is the most, what is the noise pollution that is generated by them, and so on and so forth per se. So this particular image that you can see showcases the same. Again, APY analysis. So understanding the area productivity and yield, we are one of the largest exporters of shrimps and seaweed. It is important for us to identify what are the ideal conditions under which shrimp and seaweed farming happen. Again, a lot of these things is something that our research fellows and interns will go through in depth. So I won't take too much time explaining these. But again, the idea is to how we can provide the consumers a viable product that would allow them to identify whether at that particular point, whatever nutrients they have, whatever is the pond temperature correct, are the nutrients that they have put, is that correct, and all those kind of things. So our application essentially, we are looking to develop something that allows them to analyze that, and at the end of the day, what is the probability of their production per se? What is the amount of production that they will have? We have been doing some work on climate change analysis. This is something over the next 10 years or so. This is something that we are looking at. So over the past 10 years or so, this is something that has taken into consideration. And we are looking at what is the impact in the underwater domain, how it impacts our GDP per se, and things like that. Again, I'm just giving a rough overview of it. Our research fellows will talk a bit more. And lastly, collision avoidance system. So far, we have done a work wherein we have used multiple machine learning models to effectively identify. So when a particular vessel is in a region, what is the probability of collision risk for that particular vessel with respect to other vessels as well as other land masses and other objects in the region. Last time we were at a point where we had used a mathematical model and we had created an application which gives you the probability of, for any given point in a river, at even any given point, it gives you the probability of collision of a particular vessel. But taking upon consideration the reviews that we got in the last time, wherein what happens when the AIS goes off, where AIS is not visible, we have also taken into consideration now the aspect of images that are given by NASA. So we are also doing some image processing now. That is again an interesting aspect that you'll get to see when the fellows make the presentation per se. That's pretty much all I have. Yeah, effectively pointing out that all the fellows, both this year and the year before this, have done incredible amount of work supporting MRC and supporting the larger framework of UDA. And I believe that today's presentations that you will see will be fruitful and will delve into the same. Thank you.